we're going to start with just a brief review of yesterday, and then we're going to go ahead and talk about some new stuff. I'm going to teach you guys how to multiply and divide using SigFigs. I'm going to teach you guys how to multiply and divide using SigFigs. So, here we go. So, all right, non-zero numbers, okay? When are those significant, non-zero numbers? When are those significant? Non-zeros. When it's just not a zero, when it's not a zero at all. They're always significant. There you go, yep. Always, 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 no matter what. So non-zero numbers are always significant. Now, what about leading zeros? So, for example, 0.02. Those are leading zeros because there's no non-zero in front of them. I know one of them's before the decimal, one of them's after the decimal. Okay, it doesn't matter in terms of whether they're a leading zero or not. If there's no number, like a non-zero like that one right there in front of them, then they're leading zeros by definition. So when are leading zeros significant? Never. They're never significant. So this number in blue here, that would only have one SigFig. It'd be the 2 at the end. And those two leading zeros are never significant. It doesn't matter if there's a decimal. It doesn't matter if one's before or one's after the decimal. If they're a leading zero, they're never significant. What about captive zeros? So that would be something like 701, where you have a zero trapped between a non-zero and a non-zero. When are captive zeros significant? They're always significant. Okay. But what about trailing zeros? So a trailing zero right there on the right over here. So 10.0 has a couple of trailing zeros because there are no non-zeros after them. Again, I could change that right now. If this was the one right here, this would not have any trailing zeros because there's a 1 after the last zero. But if there's no non-zero after those, there are trailing zeros. So when are trailing zeros significant? Only when there's a decimal, okay? When there's a decimal, that person's saying, hey, I know this looks suspicious like I rounded, but I'm telling you, like, I actually measured those zeros, and they happen to land, like, right on the line. Like, it says 10.0 centimeters, like, it just happened to land around the line. Whereas this person, if they don't have a decimal, they're like, yeah, it's like about 10. It might have been like 8 or 9. I'm not really sure, but it's like about 10. Okay? So there's a big difference. Now, mathematically, in terms of the size of that number, they're both 10. But 10 right here says, oh, it's about 10. Whereas this one right here says, it is 10.0. I actually measured those zeros. We know that those are zeros. Does that kind of make sense? A little bit different there. So, now we're going to talk about how we multiply and divide with SigFigs. How we multiply and divide with SigFigs. So, here's how it works. I've got this little chart here. So, 3.0 times 4.0. How many SigFigs is 3.0? I'll write those in green. So, SigFigs, SFs, 2 in green. Yep. So 3.0 has 2 SigFigs. How many SigFigs does 4.0 have? 2. And so what this will mean is that our answer is only allowed to have 2 SigFigs. So guess what our answer is? It's 12, which has 2 SigFigs. Okay, so 2 SigFigs. Now this one right here, how many SigFigs does 3.00 have? 3. What about 4.0? Now, it's all about the weakest link in the chain. So, I am still only going to call this answer 12 because it has 2 SigFigs. And when I have 2 SigFigs times 3 SigFigs, I'm only allowed to keep 2. I'm only allowed to keep 2. Now, how many SigFigs does 3.000 have? 4. What about 4.00? Okay, so who's the weakest link now? The 4.00. So how many SigFigs am I allowed to keep? 3. So I can't just call this 12 now. This has to be 12 what? 0.0. That trailing zero is significant because there's a decimal. If this were a quiz or test, if I had 3.000 times 4.00, you have to say it's exactly 12.0. 3 SigFigs. All right, what if I had 3.00 times 4.00? That's 4 SigFigs times 4 SigFigs. How many SigFigs am I allowed to keep in my answer? So this would be what? 12? 12.00. You got it. Because if that person actually measured and they know it's 3.000 and the other one they know is 4.000, then they're very confident that this is not just 12, not just 12.0, but it's like this is 12.00. Like it is right on there. Now this next one's about to get a little goofy. Okay? All right. Joey, how many SigFigs does just 3 have? What about just 4? How many SigFigs is your answer allowed to keep then? Only 1. So 12 has how many SigFigs? So 12 is no longer good. The answer of what is 3 times 4 is just going to be 1, and you have to round. It's 10. 3 times 4 is 10 with SigFigs. If I put this in layman's terms, here's what this is saying. This person's like, yeah, I estimated 3, so I'm pretty sure it's like a 3. It could have been a 4. And with that 4, they're like, oh, I'm pretty sure it's a 4. It could have been like a 5. So probably 3 times probably 4. We can't say that's 12 because we're not sure. But we can't say, oh, it's about 10 because we don't know for sure.
So if it's estimating, we don't say the actual numbers?
If it's estimating, that just means we lose SigFigs a little bit. So the last number on any measurement is estimated. So like in this one, there's only 1 SigFig. So that means the 3 must be estimated. That must mean they're not 100% sure that's a 3. Versus this person who put 3.000, they are 100% it's 3. In fact, they're 100% is 3.00.
So it could be like 3.5, but we don't know that.
Right, yeah, we don't know. We don't know. So we're just forced to assume, like, yeah, it's going to be about 10. Okay? Yep, so we lose our ability to be, like, really precise and know our answers when the two things we're multiplying together are not as clear. Not as clear. So let's go through this next one over here then. And we got 3 SigFigs, 4 SigFigs, 1 SigFig. Okay? 2 SigFigs. So we got 2 times 2. So how many are we allowed to keep? 2. So what's 2 times 9 in your calculator? 18. How many SigFigs does 18 have? Well then, that works out just fine. Nothing goofy there. How many SigFigs? 2.0? 2. 9.00? 3. How many am I allowed to keep? 2. Only 2. Okay. I'm only allowed to keep 2. I should grab this guy and kind of bring him down there. Okay. So I'm only allowed to keep 2, so this will still be 18. When I get 2.00, how many SigFigs? 9.00? So how many does my answer have to have exactly? 3. So this can't be just 18. That's only 2 SigFigs, right? It has to be 18.0. We got to put one more 0 on there. Four SigFigs times 4 SigFigs. I have to have exactly 4 SigFigs. So 18.00. Yes, sir. Whoever that was. Yep. With 2 times 9. That's a great question. What do you think? So we got 1 SigFig, 1 SigFig. So how many do we have to keep? Only 1, right? 18 is 2 SigFigs, so we can't use that. So we have to round to the, after that first SigFig. So normally, now don't write this part down. Your calculator is going to say 18, right, Damon? Okay. But we have to round after the first SigFig. So we're only allowed to keep 1. So we have to round after this 1. What does that 8 tell that 1 to do? Round up or down? Up.
So we say 20?
Mm-hmm.
So you're saying yours 10 every time?
Huh?
You're saying yours 10?
It just depends on how many SigFigs you're allowed to keep. Yep. Yes, sir. Yep, go ahead. And again, what this person is really saying, when they just write 2 and 9, they're saying, oh, I'm pretty sure it's 2 and I'm pretty sure it's 9, but it might be different. All right, so let's talk about what's the official rule. The official rule is the number of SigFigs in the weakest measurement controls how you round. The number of SigFigs in the weakest measurement, so we're writing that down in your notes. The number of SigFigs in the weakest measurement controls how you round. That controls how you round. Okay? So, let's take a look at that next section here. I'm going to go through this quick. Okay, so regardless of whatever the numbers are, if I have 3 SigFigs times 2 SigFigs, how many SigFigs do I have to keep?
2.
What about 6 times 2?
2.
What about 3 times 3?
3.
What about 6 times 1?
1.
Right.
So the smallest number.
Just the smallest number, that's how many SigFigs you're allowed to keep. So 1,000 SigFigs times 1 SigFig means you're only allowed to keep 1 in your final answer.
What if it's like 150 or 151?
What if it's like, oh, then you keep 150.
Okay.
Yeah. Now watch this. The next slide is identical to this slide. The only thing that's going to change is that these multiplication symbols return to division symbols. The rules are exactly the same. Watch. Okay? The rules are exactly the same. So if you're dividing 6 SigFigs by 2 SigFigs, you're still going to keep 2 SigFigs. So those rules don't change, okay? So just want to make sure you guys understand division and multiplication have the same rules. Now let's talk about how to round. Let's talk about how to round. This is important. And this will be our last section of notes before we do some practice problems. If you plug 135.82 times 17.00 into your calculator, I'll just go ahead and tell you, your calculator is going to spit that out. 2,308.94. So it's, around 2,000. Okay? That's what your calculator is going to say. Now, if Michael's on his quiz and he's figured out, oh, I'm only allowed to keep 5 SigFigs in my final answer, how many SigFigs does that have in blue? That's 6. He can't keep all those in his final answer. He's got to round. So what you're going to do there, Michael, is you're going to count. Okay, 1, 2, 3, 4. This is my 5th SigFig. So the 9 is the last one you can keep. He needs to round after that 9. Michael, is that 4? Tell that 9 to round up or down?
Oh. No, down.
Down.
I thought you were-
So this will be 2,308.9. If he had to round to 5 SigFigs, that's what he'd write down. Now, what if on a different problem, Aya learns that she can only keep 4 SigFigs? So here's what Aya's going to do. She's going to be like, okay, 1, 2, 3. 8 is my 4th SigFig, so you have to round after the 8. Okay, Aya?
Mm-hmm.
So you're going to round after 8. What does that 9 tell the 8 to do? Round up. So she is going to have her answer be 2,309, if she's only allowed to keep 4 SigFigs. Now here's where I'll see a lot of big mistakes. Now what if Aiden next to her, he's like, oh, I'm only allowed to keep 3 SigFigs. You're on a different quiz. You're only allowed to keep 3 in your answer. So you count 1, 2. Here's my 3rd SigFig, and you have to round after that. So what does that 9 tell that 0 to do? Round up, right? Now watch this. A lot of people are just going to put 231. So like, yeah, the 0 goes up. What's the problem with that? The problem is, we were looking at a number that was a little over 2,000, right? This is 200 something. Like, the size of the number completely changed. We're not supposed to change the size of the number. We're just supposed to round it. Okay? So, you need to put that 0 in there. But Mr. P is not 4 SigFigs? It's not? But there's a trailing 0. There's no decimal. So you still have 3 SigFigs. But do you guys see how the size of this number hasn't changed? It's still like 2,000-ish? Good. If we had to go down to 2 SigFigs, we'd round after this 3. So this would be rounding to the closest 100. That'd be 2,300. And if Ian was only allowed to keep 1 SigFig, he'd have to round after this 2. What does that 3 tell that 2 to do? Round down. So you just call that 2,000. So depending on how many SigFigs you're allowed to keep, or you have to keep, will tell you where you need to round. But just make sure you are not chopping, okay? You're not chopping, so it's not like we just chopped off everything after. You're just rounding. There's a big difference. So if Layla's doing this, especially going from 4 SigFigs to 3, she's not going to just chop off that last place. She's just rounding it over with zeros. See the difference? So we're going to go ahead and hop to the back here. Here's the back of this worksheet. Let's do 1 or 2 problems together, and then I'm going to let you guys work on your own. Okay. Warda. 18. How many SigFigs does 18 have? This is the very first problem on the back.
2.
Correct. How many SigFigs does 3.21 have?
3.
So before I even plug this into my calculator, a lot of people are just going to write, how many sig figs are you allowed to keep then? So I'm just going to remind myself right now, I can only keep 2 sig figs in my final answer before I even plug anything in. Just like, all right, okay, future Warda, make sure you only keep 2 sig figs. Okay. Now, if you were to plug this into your calculator, 18 times 3.21, you'll get 57.78. How many sig figs does she have to keep, though? 2, right? She's got 2 sig figs times 3, so she has to keep 2. So, Warda, where's your second sig fig? So this answer's got 4 sig figs. We can't keep that. Where's the second one? Yeah, that first 7. So you have to round it after that first 7. So what is the second 7 tell the first 7 to do? Round up. So what is your final answer going to be? You got it. There you go. All right, so that is a wrap for today's SigFig notes. I will bring around an answer key. If you're watching this video at home, the answer key is below the video. All right, folks, let's get to it. Here you go.